Good morning, everyone. Today we will going to see some practice questions from the chapter Biomolecules. This is part 1. Let's start. Disclaimer. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Moving on to the index. Practice questions from 1 to 8. Let's start with the first question. Question number 1. Which of the following biomolecules contains a non-transition metal ion? We have given some biomolecules in our option and we have to tell that which of the one biomolecule contains a non-transition metal ion. Non-transitional metal ion belongs to the D group from the periodic table. The options are hemoglobin, chlorophyll, insulin, or vitamin B12. You have 10 seconds to think about this question. After that, we will see the answer. Okay, let's move on to the answer. So the correct answer for this question is option B, that is chlorophyll. How? Chlorophyll is a biomolecule, we all know, that contains magnesium ion Mg2 positive, which is a non-transition metal that is held at the center of porphyrin ring in the chlorophyll. So basically, chlorophyll is a biomolecule which is having a magnesium ion which is holding at the center of porphyrin ring in the structure of the chlorophyll. That is why we are saying that chlorophyll is a biomolecule containing non-transition metal ion, because magnesium 2 positive ion is present in the structure of the chlorophyll, which is held in the center of the porphyrin ring. And that is why we have our correct option as option B, that is chlorophyll. Let's move on to the next question. Question number 2. Which of the following monosaccharides is a pentose? So you have to tell from the options that which monosaccharide is a pentose. Pentose means carbon, 5 carbon. Okay, number of carbons present will be 5. Options are glucose, fructose, arabinose, or galactose. You have 10 seconds to think about this question. After that, we will see the answer. Let's move on to the answer. So we have the correct answer of this question, which is option C, that is arabinose. Arabinose is a monosaccharide, which is a pentose sugar. Okay, so basically all the options given in the question are monosaccharides, but we have to tell which is the one particular monosaccharide which is pentose having 5 carbon in it. So basically, in the structure of arabinose, there is number of carbons present is 5, and arabinose is a monosaccharide which is a pentose sugar, and that is why the correct answer is option C, that is arabinose. Let's move on to our next question. D-glucose contains, so the D-glucose contains which of the correct option? Okay, so you have to tell the particular amount of some D-glucose type. Options are 50% each of alpha D-glucose and beta D-glucose. So in the D-glucose, equal amount, that means 50% of alpha D-glucose and 50% of beta D-glucose is having. or 64% of alpha D glucose and 36% of beta D glucose, 36% of alpha D glucose and 64% of beta D glucose, or 33% of each alpha D glucose and beta D glucose. So you have to tell which is the correct composition for the D glucose. You have 10 seconds to think about this question. After that, we will move on to our correct answer. Okay, let's see. So the correct answer for our question is option C, that is 36% of alpha D glucose and 64% of beta D glucose. How? So D glucose contains 36% of alpha part and 64% of beta part of D glucose. So basically, D glucose, we can arrange the D glucose structure in the two forms, alpha D and the beta D1. But they both are the components of the D glucose, right? But mixture of the both, alpha D glucose and the beta D glucose, forms the D glucose whole structure, and that is why the composition, the correct composition for the alpha and beta part is that 36% of alpha D glucose and 64% of beta D glucose is present in our D glucose. And this is the question, and that which amount of correct composition of alpha D and beta D part for the D glucose. So we have our correct answer as option C, 36% alpha D glucose, 64% of beta D glucose. Okay, let's move on to the next question. Glucose on prolonged heating with HI gives. So if you heat the glucose with HI for long time, okay, so what will you get? Options are N-hexane, 1-hexene, hexanoic acid, or 6-iodohexanol. You have 10 seconds to think about this question. After that, we will see the correct answer. Okay, let's move on to the answer. So the correct answer for our given question is option A, that is N-hexane. HI, hydrogen iodide, is a strong reducing agent. Reducing agent means which reduced to the other and oxidized itself and gets oxidized itself. So HI is a strong one, strong reducing agent. It reduces both primary and secondary alcoholic groups of glucose along with the carbonyl group to produce N-hexane. So in our glucose, both primary and secondary group of alcohol is present. Okay, so HI is a strong reducing agent which can reduce both primary and secondary both. Along with that, it can also reduce the carbonyl group, the carbonyl part, that means C double bond O part of the glucose to give us N-hexane. As you can see in the diagram, we have the structure of glucose having the carbonyl group as CHO, which is an aldehyde group, CH double bond O, and the secondary alcoholic group, which is CHOH whole 4. Why secondary? Because the hydroxyl group is attached to the carbon, which is directly attached to the two carbons, right? That is why it is a secondary alcoholic group. And we also have a primary alcoholic group in the structure of glucose. Primary alcohol, again, because hydroxyl group OH is directly attached to the carbon, which is attached to the only one carbon, right? Directly attached to the one carbon only. That is why it is a primary alcoholic group. And when you heat the glucose with the HI, hydrogen iodide, like prolonged heated, you will get N-hexane. So what HI will do? HI is a strong reducing agent. It acts as a strong reducing agent, and it will reduce both like carbonyl group and secondary and primary alcoholic groups and give us N-hexane. Okay, that is why we have our correct option as option A, that is N-hexane. Moving to our next question. The two forms of D-glucopyranose obtained from the solution of D-glucose are called. So we have asked that D-glucopyranose. Okay, the two form of D-glucopyranose which obtained from the solution of D-glucose, which will we get from the solution of D-glucose? What we called that two forms. Options are isomer, enomer, epimers, or enantiomers. You have 10 seconds to think about this question. After that, we will see the correct answer. Okay, so let's move on to the answer part. The correct answer for our given question is option B, that is enomer. Two forms of D-glucopyranose are alpha 1 and the beta 1. Okay, so basically D-glucopyranose having two forms, alpha 1 and the beta 1, and these are called enomers. They both are called enomers of each other because they only differ at C1 configuration. The carbon at the first position, so the alpha part and the beta part are only different from each other because the configuration around the first position carbon is different. As you can see, this is alpha D-glucopyranose, this is beta D-glucopyranose, right? We have said that around the first position of the carbon, the configuration is different in both. So you can see that C1 is here and in the alpha D-glucopyranose, and in the beta D-glucopyranose, C1 is this. You can see the hydroxyl and hydrogen present in the first position of carbon is the configuration is different. Like hydroxyl group is present at the right side in the alpha D-glucopyranose, while the hydroxyl group is present on the left side in the structure of the beta D-glucopyranose at the first position carbon at the C1, right? And else all the configuration is same around each and every carbon in both alpha and D form of glucopyranose, right? And this concept that if around a particular carbon the configuration is different between the two structures and rest of the structures are same, they are called enomers, and that is why the two forms of D-glucopyranose, which is alpha and beta, we call them as enomers. That is why we have our correct answer as option B, enomers. Moving on to our next question. The reagent which forms crystalline osazone derivative when treated with glucose is. We have to tell the name of the reagent which forms crystalline osazone derivative when it is treated with glucose. The options are Fehling solution, phenylhydrazine, Benedict solution, or hydroxylamine. You have 10 seconds to think about this question. After that, we will see the answer. Okay, let's see. So the correct answer for our given question is option B, that is phenylhydrazine. The glucose, when we treat the glucose with phenylhydrazine reagent, phenylhydrazine is 3 moles of C6H5NH.NH2. So when you treat glucose with the phenylhydrazine as a reagent, it will give us glucosazone, which is a osazone derivative, right? Crystalline in nature. CH double bond N NHC6H5, C double bond N NHC6H5, CHOH whole thrice, and CH2OH. This is a structure of glucosazone, which is a osazone derivative. And this is the question, that when you treat glucose with a particular reagent, you get the derivative of osazone. What will be the reagent? So the reagent is the correct answer, which is option B, phenylhydrazine. Moving on to our next question. The reaction with sugars are carried out in neutral or acid medium and not in alkaline medium, because in alkaline medium sugars undergoes what? So we have some information that when we when we do the reaction with the sugars in the neutral or acidic medium. So basically our reaction is with sugars and we do it in the neutral or the acidic medium, but not in the alkaline medium. Why? Because in the alkaline medium, sugar undergoes some process. Which process? You have to tell. Okay. So options are decomposition, racemization, inversion, or rearrangement. You have 10 seconds to think about this question. After that, we will see the answer. Okay, let's see. So our correct answer for the given question is option D, that is rearrangement. In the alkaline medium, sugars undergoes rearrangement. So basically when we do the reaction with the sugars, if we use alkaline medium during the reaction, the sugar molecule will undergo the rearrangement and it will rearrange itself and form another molecule. That is the reason that we use either neutral or acidic medium while performing any reaction with the sugar and not the alkaline medium. Okay, because the sugar undergoes rearrangement. And this is the question, that the alkaline medium, if we use alkaline medium, which process the sugar undergoes? So the correct answer is option D, that is rearrangement. Moving on to our next question. Optical rotations of some compounds along with their structures are given below. Which of them have deconfiguration? So we have given some structures here, first, second, and third. Positive rotation, negative rotation. You have to tell that the optical rotation we have given, positive, positive, negative. You have to tell that which of the following is having deconfiguration. Options are first, second, and third, first and second, or only third. You have 10 seconds to think about the question. After that, we will see the correct answer. Okay, let's see. So the correct answer for the given question is option A, that is first, second, and third. That means all the structure will be giving us deconfiguration. In all the three structures, wait a minute. Yeah. In all the three structures, first, second, and third, okay, the given structure, the configuration of hydroxyl group at lowest asymmetric carbon is towards right, and hence all have deconfiguration. So we use this concept here, that at the lowest asymmetric carbon, like this one, this one, this one, or you can say this one, this one, this one. Okay, so at the lowest asymmetric carbon in the first, second, and third structure, the OH configuration around that is towards right. In the first structure also, the lowest carbon is having OH group at the right position. In the second structure also, it is in the right position. And in the third structure also, it is hydroxyl group is in the right position. That is why all three will be giving us deconfiguration, right? And this is the question, that which of the structures will give us or will be having deconfiguration. So all of them will be having deconfiguration, and that is why we have our correct option as option A, first, second, and third. Okay. Thank you.